Now we move on to talk about selection and indexing. How do we select some subset of a spreadsheet? What if we want the columns? This is the data, right? Man, this is so long. Well, the data is sitting here. I want, say, column W. So we'll type the name of the data frame, which is DF, square bracket, and within the square bracket, ask for W, and then it will give you minus 1.38 through 0.68. It stays in the first column. So that's how you grab the columns of interest. Data frame, square bracket, the name of the column as a string, right? And then you get the first column, or the column labeled W. What if you want both the columns W and column Z? Remember, there's a column Y between W and Z, right? I want both W and Z. Well, provide it as a list. So this is a list of the strings which correspond to the column headers. And then you get both columns and, of course, all of the rows. Like I said before, data frames are just combinations of multiple series, right? Which is multiple columns. Combine multiple columns, then you have something that looks like an array, but within the context of spreadsheets, what you have is like a spreadsheet. It is a data frame. So your data frame columns, one column from your data frame is just a series. And so if you do the type of the data frame and you ask for only one column, then it tells you it's a series and not a data frame, right? What if you ask for the data frame itself? Then it's a data frame. Very important. Series are different from data frame. Series will correspond to one column in the spreadsheet or data frame. Good. How do we create a new column? Just provide the name of the new column, square brackets, and then you can either type in a new value or calculate it from a combination of the data sitting in the other column. So you can sum up the values stored in W and the values stored in column Y, right? And you access them like we access these ones, right? So access the first column, the second column, add each item in them together, and then store it in a new column. Where does it put the new column? Obviously at the back end, right? So it appends a new column to these columns we saw before, which went from W through Z. And now you have a new column titled what? New, because that's what you gave it as the name right here. So if you run this, and you have everything you had before plus a new column that basically added each item in W to each item in Y, according to the equation. I already explained this. I'm not going to talk much about it. You want to print it, you don't need to use a print statement. It just has to be the last command in the cell. If you want to print multiple, create multiple cells with this plus sign and have the data frame sitting in there as a last command. You can drop any of the columns. We can drop this new. Maybe we don't like the result. We want to do something else. So drop data frame.drop, then the name of the column you want to drop and the axis. Now this is kind of different from the axis arguments we talked about in NumPy. In NumPy, when we said you sum along axis 0, 0 goes from where? Top to down first, right? And then axis 1 is from left to right. So if you want to do NumPy sum on this, say, multi-dimensional NumPy array, it isn't a NumPy array, it is a data frame. If it were a NumPy array and you do sum with axis equals 0, because axis 0 goes from top to down, it's going to go sum up going from top to down and get you 5 sums, right? One sum for each column. If you sum with axis equals to 1, it sums left to right and it gives you one value for each row here. But here, when you're asked to drop and you say axis 1, the way you can think about it is axis 0 is the rows. The rows come before the columns. Axis 1 is the column. So when you say axis equals 1, you're asking to drop a column. And that column is named new. That's what the first argument does. So you basically drop off this, and then you can see right away that the column is gone. What if I run df? It should just print the same thing, right? No, it doesn't. Why? Because even though you thought you dropped it, you didn't change the actual value in memory. So to change it in memory, you use what is known as an in-place function. An in-place argument. So you need to set in-place to be true, meaning this drop, do it in place. And in computer science, in place means in computer memory. So don't just display a data frame that has it dropped. Do that drop in place or in memory. So drop it in the computer's memory. And when you do that and you print df, it's gone, even after printing df by itself. Now, there is something that could be confusing online, because online you may see, it looks like some people are able to use the df.drop without using the in place, and it works. There is another way to achieve the same thing, and I'll show it right here. So it's df equals to this. You see, it's different than if you take it out. So if you do this, so let's bring back the new. How do we bring back the new? Go run the line that has the new function, right? So now the new is back by running that part. And then we come back here. Where is it? Here. This is what I've just done. I've added data frame equals data frame dot drop. So this will drop it. And instead of just displaying it, we save the version of the data frame that has that new axis dropped into a new data frame, and then this will be dropped. Even if you create a new cell and you ask for df, it's still dropped. So we didn't have to use in place. The only thing is we have had to use df equals. So two ways to do the same thing. Df equals this without the in place, or remove this and then do comma in place equals true. I hope that's clear enough. So two ways. This will drop it permanently from memory, and this will not run right now because new does not exist. We just dropped it. So it gives you an error. So when you start to have errors, think about what's going on. You're trying to drop something that doesn't exist in memory. So you will have to go create that new column again, and this is the command that creates it. So we create it, and now we are back to this form, which uses the in place equals true. So two main approaches to drop it from memory. In place equals true this way, or df equals df.drop, and then you don't have the in place. We keep moving. We can drop rows, right? The previous example was to drop a column new. We can drop row E by using the same function, df.drop, and then you provide the name of the index of the row, and then axis equals 0, 0 for rows. So you're dropping a row, and the name of the row you're dropping is E. And then we run it, and it drops it. But does it drop it from memory? No. You have to put comma in place equals true to drop it from memory, or df equals df.drop, whichever one you prefer. Or many times you have several different ways to skin a cat in Python, different ways to do the same thing, and you only need to know one correctly. So this will drop it completely from memory. We can select rows using df.lock. Lock is like location, right? So df.location A. What's that going to do? It's going to give you all the items in row A. Remember, the row is the name of the, A is the name of the row, is the index of the row. So that will grab all these items. So you will see minus 1.38 as the first item, and the fourth item, which is the last, will be minus 2.142. And that's what you get here. It also gives you the names of those columns corresponding to the value. So column W through column Z. What about grabbing it from their relative position and not the names of the columns? So we know this is the first column, the second column, third column, this is the first row, second row, and so on. You can also do that. But if you're not going to be using the names of the names or the indices of the rows, you can use iloc. So it's the location, but in terms of its index, its numeric index, right? This is ABC. That's the name of the index. Then you can grab it from its relative position in terms of numeric index, meaning this A is at position 0, B is at position 1, C is at position 3, because indexing in Python starts from 0. Good. So if you ask for iloc 2, you're asking for the third item, right? Because this is location 2, it's location 1, location 0. So another way to grab it, you can use iloc, you can use loc. With loc, you have to put the string representing the name of the index. With iloc, put the relative position starting from 0. Get the same kind of results. Selecting subsets of rows and columns, you can provide using the loc, which requires the names of the columns and rows. B will be the row, Y will be the column. Always row before column. And remember, this is a comma, not colon, right? So colon is when you're trying to grab a range. Here, it's both the row and the column. So it will give you just one number. It is the number at row B, column Y. So this is row B, and this is column Y. So it's going to give you this number, minus 1.04. That's it right there. How about multiple rows and multiple columns? Well, provide the rows in square brackets separated by commas. Again, this is not column, so it's not a range. It's all the rows you itemize and all the columns you itemize. So you put both of them in lists separated by a comma. Whereas here you just provided single strings separated by a comma. So this will get you, I can comment this because I will give you it's a similar result, different ways of accessing the same thing. So give me rows A and B and columns W and Y. So it goes in here, rows A and B. So these first two, and then this column, first column, and the third column, right? We skip this. So it will give you minus 1, 3, and this on the first row, on the first column, and this and that on the second column. That's what you obtain from that function. Like so. So it's columns W and Y, the columns you asked for, and the rows you asked for A and B, using the loc. What if you want to use their relative positions? iloc. And now A and B correspond to the first and second columns, right? Sorry, first and second rows. So it's going to be 0 and 1. Again, this is not going to start at 0 and stop at 0, which is one short of 1, because it isn't a column. This is a comma. So if you wanted 5 items, you have 0, 1, 2, 3, and so on. Or you can use the column. I believe you can use the column actually. And like I said, always test it out. You can use the column. I said this will now be 2, so that gives you 0 and 1. And this should work. No, it doesn't. So in this setup, you have to itemize it. You have to itemize it. So if you want 0 through 10, you got to keep listing it out and so on. So this will give you 3 rows. But because we wanted the first and second, you do 0 and 1. So it's inclusive because it's 0 and 1. It's not a column. And here is 0 and 2. So we skip 1 here because we asked for Y. I mean for W and skipped X and asked for Y. And then the result is identical to the previous. So 2 ways to achieve the same result. And we'll stop here and discuss the rest of this in the next video.